presentation about the best practices for source water protection. Following that presentation, you'll get into the main reason why you're here is for our WellCare 101 presentation by our expert, Melissa Lee from the Ministry of the Environment, Conservation and Parks. After that, we'll be going into a Q&A session. Thank you to everyone who submitted a question with your registration. There was almost 50 questions, so thanks for that. We unfortunately will probably not be able to get through all of them, but we did try to sort of consolidate a lot of the sort of main themes of the questions. So if your question doesn't get answered, you can reach out to us afterwards, and we'll try to get back to you on that. All right. So begin, let's talk about the best practices for source water protection. So the best practices is a voluntary ministry guidance that aims to protect drinking water sources that are not protected by the Clean Water Act and a source protection plan. The document provides helpful information and suggestions on how private system owners can protect their drinking water sources. So as you may know, Ontario has a pretty comprehensive drinking water source protection program, but it's always primarily been focused on municipal sources of water, and a lot of our population in Ontario relies on private systems that fall outside of the Clean Water Act. So the Clean Water Act is something that came out of the Walkerton tragedy, where basically the whole town and numerous people tragically died from the municipal drinking water sources getting contaminated. So this best practices document takes sort of the lessons we've learned from that program over the last decade or so, and then looks to how to apply it to rural private system owners. So some of the advice you can look to find in the best practices include simple and effective protection measures, like informing you how and why to test your drinking water regularly. They recommend about 3 to 4 times a year. Easy way to remember is seasonally testing it. So there's different threats can come about in different seasons. For example, in the winter, road salt can be a potential contaminant, and then spring and summer sort of agricultural threats might pose more of a danger. It can also help create an inventory of potential contamination activities. So just being aware of the potential threats on your property. It can inform you how to implement a protection zone around your drinking water source. So this comes directly from the sort of municipal source protection plans, where they're usually known as wellhead protection areas or intake protection zones. So the sort of director technical rules from the Clean Water Act, for example, recommends using just 100-meter radius around your well. And so then you can sort of monitor potential threats that are within that radius. I'll teach you about how to visually inspect your well and septic system. We'll get into the well component about that shortly. Pumping out your septic system every 3 to 5 years. Septic systems are a big potential threat to your private drinking water source. If you weren't aware, next month, November 30th, we're actually having a additional webinar specifically on septic systems and how they can affect your drinking water. So if you haven't registered for that, you can look for the link to do so. I'll also advise you to use eco-friendly alternatives for commercial products, so just potentially less harmful products. Big proponent of source protection deals with water quality, but of course water quantity is also an issue. So be aware of sort of certain times a year where you might need to conserve your water when possible. Disposing of hazardous waste at the appropriate location. So if you know of potential hazardous waste on your property, generally a good idea not to leave it out exposed where it could potentially leak into your aquifer and your groundwater and then potentially get into your well. Fuel tanks are a big hot topic in municipal source protection, so of course they're going to be important to maintain if you have a private system. So installing a double-walled tank is a big way to help with that. If you're on a waterfront property, consider a land buffer to reduce your surface water runoff. And if anyone was at our harmful algal bloom webinar last month, big issue from that is runoff from properties into water. So if you have a intake, drinking water intake, that can be a big potential threat to that water source. So to learn more about what you can do to help your property, I think we have a link in the chat. So why is it important to implement the best practices on your property? There's a few reasons you might consider implementing them. The big thing, again, going back to why the whole source protection program really came about, it goes down to human health. Or if you're regularly drinking water from a well, you want to make sure that it's not going to potentially make you sick. So that's really sort of the crux of why this whole kind of program exists. But it also can have lots of other benefits, like cost saving. Cleaning up a contaminated drinking water source can be very costly, especially if it's a source of contaminant such as dense non-aqueous phase liquid, or DNAPLs as we like to call them. They're nasty, non-soluble in water chemicals that can be really hard to clean up. You can also save water and save money on having to find a new source of drinking water. So having to drill a new well and decommission your old well can be quite costly, as well as treating potential contaminants in your water can also be expensive. The best practices are also important to help extend the life of your system. I think we'll probably get into some of that in the well care with well maintenance. It can help you make informed land use planning decisions. So this can be things such as even just sort of considering where you might be building a garage or a shed on your property, where you might be storing those potential chemicals or contaminants, or where your septic system's being installed. It can also increase public awareness and accountability of drinking water stewardship. So as you all know, if you're on a private water source, you might be sharing that with your neighbors, or you're probably sharing that groundwater, the aquifer, with neighbors. So you might think that even if you could be contaminating your groundwater, and depending on where sort of your well is in relation to your neighbors and the contaminants, you could be contaminating your neighbors without contaminating your water and without even realizing it. So it's important to understand this sort of we're all in it together component of drinking water protection. So as you can tell, there's a clear resource gap in between municipal and private drinking water systems. So all the blocked out items on the right are not provided to private systems owners, and it is their responsibility to protect, treat, and test their water supply. So the big the kind of strong component of why our municipal source protection program works so well is that it's this multi-barrier approach. So there's all these steps along the way, making sure that your water is going to be clean by the time it gets to you. So there's various experts and planners and scientists all sort of working to make sure that water that comes out of your tap, if you're on municipal water, is clean. If you're on a private system, all of those experts aren't there, so you have to be that expert, really. So the goal of the best practices is to remove those barriers for private systems owners and provide them with a better level of resources and support. So if you're interested in learning more about the best practices, please contact your local conservation authority. Some conservation authorities have additional resources like a staff member to provide an assessment of your property to identify contamination risks and provide suggestions on how to lower your risk of contamination. Additionally, some conservation areas, depending where you are in the province, may have stewardship programs to help subsidize some of the costs for implementing preventative measures like well upgrades and decommissioning. So that concludes our short presentation on the best practices. We'd like to now introduce and welcome our guest speaker for today. Melissa Lee is the Wells Division Program Specialist at the Ministry of the Environment, Conservation and Parks. So without further ado, I'll let her share her screen now to take over her presentation. So over to you, Melissa.
Okay, thank you, Trent. We're just loading up. Here we go. You can see that, Trent?
Yep.
Okay, perfect. Okay. Oh, sorry. Oh, 1 second. It turned, I don't see my notes, just a minute. Sorry. Okay, let's try that again. Okay. So thank you, Trent, and good evening to everybody that's on this call. My name is Melissa Lee, and I'm pleased to be here today to share with you some information about our WELLS program at the Ministry of Environment, Conservation and Parks. So thank you for taking time out of your evening to come and learn about that. So I've been with the ministry for 13 years, working for most of that time as an environmental officer in the Cornwall and Ottawa offices in Eastern Ontario. And as an environmental officer, my work included mainly compliance response, and that included attending well incidents like complaints that wells were contaminated, improperly constructed, leading to some contamination, improperly decommissioned. And now in my current role as program specialist, it includes offering guidance and developing tools and resources for our frontline staff to better deliver the compliance goals of the WELLS program. And as Trent already mentioned, we're going to just keep your questions for the end, or you can throw them into the chat during the presentation. I'm estimating that the presentation will take about 45 minutes to get through. And then after that, we'll have some time for some questions. And as Trent pointed out, also, we had about 50 questions that we sort of themed into different groups. And so we have some answers already prepared for some of those common questions. And then also with me tonight from the ministry is my supervisor, Andrew Morley. He's worked for as long as I've been with the ministry on this WELLS program. And then also Shelley Kilby, she's our Water Wells help desk coordinator and the director in the WELLS regulation. So she's in charge of issuing licenses to contractors and technicians. And so if there's a need at the end, they're there as the panel for questions. So tonight we're going to cover some basics about wells, how they work, how they're regulated in Ontario, how licensing works for people involved in the construction of wells, how new wells are required to be constructed, how wells should be maintained, and when a well should be abandoned. Throughout the presentation, we're going to reference resources that are available to you as well owners, and links to those will be included in the chat, and we encourage you to add those to your browser. You might even want to create a folder and call it well care or something, because there's about 8 pages that we're going to reference that you might refer to over and over through the course of your time as a well owner. And just because I'm worried about lag, I'm going to turn my camera off, but I'll turn it back on at the end for questions so we could just focus on the content. Okay. So in Ontario, there's an estimated 2.5 million people who rely on groundwater as a source of drinking water for domestic use. And this is really divided into two groups, the people in the communities that are serviced by a municipally owned communal well supply, or those that rely on private wells. And that means a person who has like a well on their individual property. Approximately 827,000 well records have been forwarded to the ministry, and we receive about 30,000 annually. And here at the ministry, we have a really useful and helpful tool that's available to the public to look up all well records that have been submitted and uploaded. It's known as the Well Records Map, and if there's time at the end, I'll even do a little demo so that you could see how it works. Um, and this works because a well record must be produced by the person who did the work to construct a well, and that well record needs to be forwarded to the MECP and also given to the well owner. And these records become available to the public. And just in case you're wondering, all personal information is redacted from those records. And it serves as a tool to identify wells in your area, how they were constructed, how deep they were. It also serves as a really useful tool to us at the ministry to better understand the geology in a given area. When we're investigating a groundwater issue, for example. And this particular image on your screen is zoomed into the very east of Ontario near the town of Cornwall. And as you can see, the screen is lit up with blue dots, and those all signify well records. And even though you might think like a lot of this area along the river is serviced, and that's true by, municipal supply that's sourced by surface water, the dots all signify abandoned wells or wells that might still be in use, and they're not all just drinking water wells either. Wells and the whole regulatory framework around wells in Ontario is really centered on protecting groundwater for the most sensitive known use, and that's drinking water. It's also centered around protection of the groundwater resource for this most sensitive use. But that doesn't mean that every well is used for drinking water. Wells can be found supplying water to homes, supplying water to communities and cities, supplying water to industrial or commercial operations. Many industries will drill a well even if it's in a serviced area, just because they may have such a large demand that can't be met by the municipal supply. Wells can be used to dewater during construction, or in quarries. They're often used in agriculture for farm practices, for mixing fertilizers, cleaning dairy equipment, irrigation, groundwater testing, and monitoring. You can have dozens of monitoring wells just at one landfill site. And then also there's another use for geothermal. I'll point out to you that if there is a very large consumption of water from a well, over 50,000 liters per day, it's subject to additional permits from the ministry that are there to protect against overuse of the shared groundwater resource. These are known as permit to take waters. And so most of the golf courses that you're familiar with around you probably have a permit to take water for irrigation of their greens. Domestic use is exempt from permits to take water, but generally the volumes used in a domestic well never exceed the 50,000 liter per day threshold. So before we begin talking about the requirements and best management practices, we'll cover what a well is, how it works, and these slides include some maybe new terminology and images to help add some context to the rest of our discussion. In Ontario, a well has to meet the definition of a well. So in general, it includes anything that is a hole in the ground intended to obtain groundwater or test groundwater. And it can even include a spring, which is what you would call groundwater naturally exiting at the surface of the ground, as long as there's equipment in that spring to obtain groundwater for consumption. But it doesn't include other holes like ponds or ditches that have maybe similar equipment installed, because they're not taking groundwater, they're taking surface water. And so a typical shore well, for example, is kind of a misnomer because it's not really a well, because the source of water is the surface water. I have a little laser pointer I'm going to use, I think. Oh, here we go. Here's a cross section of two different but typical wells constructed for domestic use. The image on the left here is the dug well, and that is a well for which the hole was dug manually or with machinery. And these wells tend to be used to access an aquifer that's shallower, and they usually have a wider diameter. The image on the right is a drilled well, and that is a well for which the hole was drilled, often into bedrock, to access a deeper aquifer that could not be accessed through conventional digging, and then they tend to have a smaller diameter. Both wells function by drawing groundwater into the base of the well from the aquifer into which they were developed. A pump is used to move water from the base of the well into or out of the well and into, this pump conduit would go into the home or into the location it's being used. Um, because the well is developed into an aquifer under normal conditions, the well water level would remain fairly consistent, but can vary. So the supply is supposed to always be available. So here we'll talk briefly about how wells are regulated in Ontario and specifically by the Ministry of Environment, Conservation and Parks. So this part might be a little uh, wordy, but we'll get through it quickly. So there are a number of agencies that are listed here that have varying degree of oversight of wells and well water quality in general. And keep in mind that this is a simplification and does not dive into the details of the regulatory framework of safe drinking water. So at the very far left, Health Canada is our federal partner, is a leader in water quality management. They establish drinking water quality guidelines, provide general advice to well owners. At the provincial level, in public health protection, which is administered through the Ministry of Health, Public Health Ontario, and your local health units, they develop programs to connect well owners directly with health-based advice for drinking water. They're also your first resource for any quality-related issues and offer free bacteriological water testing for anyone on a well. The Ministry of the Environment, Conservation and Parks complements the public health mandate by delivering programs to protect the natural environment and human health by developing safe drinking water programs, regulating municipal water treatment plants, and administering the requirements under the important legislation, including the wells regulation. OMAFRA, or the Ontario Ministry of Agriculture, Farms and Rural Affairs, provides advice for safe groundwater and well use to the rural and agricultural community, and conservation authorities deliver watershed-specific programs to their watershed areas to protect natural resources, including source water protection programs. So this presentation is really focusing on our role at the MECP and the wells regulation, although throughout we will reference resources that are published by other agencies. So the two pieces of legislation that form the framework for the ministry's water wells program are the Ontario Water Resources Act and the Wells Regulation. So the Ontario Water Resources Act, or the OWRA, is a broad-reaching law that outlines the basis for the wells licensing program and director powers under that program to issue, refuse, or revoke licenses for well contractors and technicians. Then the wells regulation, which details the more specific requirements relating to wells, includes minimum construction, maintenance, reporting, and abandonment requirements. It also outlines the important responsibility of the well owner to properly maintain their well to prevent the entry of anything from the surface water, and foreign materials. There are also two important guidance documents that support the regulation. The first is the water supply wells requirements and best practices. It's sometimes referred to as the guide or the manual. It delivers the context and detailed explanation of the requirements in the regulation and the expectations set out to all of the regulated parties in this regulation. It's a really great and helpful resource to even our staff in assessing compliance for the licensed community and the well owners to understand their responsibilities. It's kind of a hefty document, but a very thorough resource, and we don't have all that many in government that are this helpful and in plain language. There's also a series of technical bulletins that were developed to provide a summary of the most popular issues around wells on equipment installation, well maintenance, abandonment, etc. Both documents have graphics and images to provide examples. They're written in plain language. They're both available on our website. The links to them will be added to the chat. All of the information in this presentation actually comes from these two documents. So a question you might be asking yourself is how the ministry delivers this program. And we are lucky in the ministry that we employ a number of very skilled professionals from various technical backgrounds that enable us to develop this legislation, policy, and guidance. It's both protective of the environment to human health and reasonable for the regulated community. So we employ groundwater specialists, engineers, geoscientists that are available to our officers to help assess and develop a response to a given well issue. Our officers are trained in the technical and regulatory aspects of the program and will be the first person you interact with if you ever have an issue requiring a ministry involvement. The Spills Action Center is a resource to report any spills, observation of contamination or gas from your well. It's open 24/7. It's an emergency response call center. They can dispatch an officer at any time of day or contact other agencies to ensure that the response received is appropriate. And the Wells Help Desk is there for when you have inquiries about well records or if you want to learn about a contractor being licensed, um, or you have any other inquiries related to wells. So here we're going to outline the basic requirements of water well construction, starting with licensing requirements for construction. Natasha, do you want to mute everyone that's on the call?
You should be good to go now.
Oh, okay. I unmuted myself. The licensing requirements for the wells regulation helps ensure that the people involved in well construction have a minimum level of knowledge and experience working on wells to help protect the drinking water of the person obtaining the well and the surrounding groundwater users, as well as protecting the groundwater resource itself. License holders must also have a minimum liability insurance in place to address any potential problems that may be encountered during construction. And yes, these do happen even with the most experienced contractors and technicians. Um, Licenses are issued to contractors and technicians. Contractors are the businesses involved in well construction, and technicians are those who actually, the people that actually do the construction of the well. There are exemptions that we, make you aware of for obtaining a license. A property owner or a member of their family or someone working for no payment or registered professionals like professional um, engineers are exempt from the licensing requirement, but it's not a recommended practice to have unlicensed professionals doing the work. Construction of a well must still be done in accordance with the regulation, regardless of your licensing status. And as you will see in the next slides, the steps that are required to conduct the construction, the equipment, the materials, expertise needed just to comply with the well's regulation will often exceed the average well owner's abilities and resources, not to mention the liability someone takes on should there be any issue encountered during the construction. Even properly completing a well record would exceed the abilities of the average well owner, to be frank. So in terms of licenses, there are 5 classes of licenses for technicians in Ontario, which will dictate the type of construction work they are permitted to undertake. Each of these classes requires training, passing an exam, and obtaining and maintaining licensing status, which means ongoing education. If you hire a well technician, you want to ensure that they hold the class of licenses required to conduct the work. So a class 1 license is good for well drilling. A class 2 is good for well digging. Those are the 2 wells we're kind of focusing in on here. You also need a class 4 license to do pump installation. So if you have any questions about that, there's a good table in the guide, but you can always call the Wells Help Desk, and we provide that phone number and email at the in the chat later on. These are examples of what well contractor licenses and well technician licenses look like. So the well contractor is on the left, the technician on the right. There'll be an expiry date listed on both of these. And also on the technician license, you'll see the classes listed here where there's 5 spaces of what licenses they have. There may be more than one. So now we're going to cover the general steps of construction. The focus here on the two most common types of wells constructed for domestic purposes, and those are the drilled and dug wells that we saw a cross-section of earlier. So the first thing you want to do is consider where you're going to place your new well. And you really want to site them where they can be accessed for maintenance, repair, and abandonment when that time comes. And as such, new wells cannot be placed inside of buildings, although we do recognize that this is the case for some existing wells. It should also be sited at a higher elevation than the immediate surrounding area, and if possible, to reduce the risk of sources of contamination being drawn towards the well. It should also be sited where there can be a minimum separation distance from sources of contamination, and additional guidance is provided in the guide on what those minimum separation distances should be. This figure shows a number of different sources of contamination on a farmstead. This is just an example. There's a septic field, an above-ground fuel storage tank, a barn, presumably has manure storage inside. There's also a drive shed where you're parking your tractors and things like that, and maybe it also has chemical storage and pesticides in there. And all of these have potential to cause contamination to the aquifer. And it shows the variability. This picture also shows the variability of the terrain at the ground surface and the presence of two aquifers below ground. It's illustrating that the well located up gradient of the sources of contamination, that would be this one over here, is drilled into the deeper aquifer, and it will be less likely to encounter these contaminants than the well that's located beside the barn that's in the shallower aquifer. So this looks like it could be a dug well, for example. It's a wider diameter, it's in the shallower aquifer, and this one over here maybe is a drilled well. It's also located up gradient, and so it's less likely to encounter those contaminants. And so this is something to consider whenever you're selecting a new location for your well. Here are two examples where the placement of the well, or vice versa, the placement of the farm animals and fuel storage, didn't consider the presence of the well, and so the risk of contamination to that well is higher in these two situations than they would be in the example in the previous slide, for example. So once you've selected the site for your new well, you would want to consider the type of well. The limitations of your property size, the topography, or some of the known groundwater depth may decide some of this for you. Sometimes we don't have that much choice, but we still encourage you to decide these things with professionals like a licensed contractor and technician. Another way to help you determine what kind of well you are likely to require is to access our well records map and see what depths of other wells around you have been constructed and what the types of wells that were constructed. And so now that you have all of that sorted out, you begin construction. And so in these next slides, I'm going to outline the very basic steps of construction. And it is a very technical thing, so I'm not trying to oversimplify it, but I do recognize that maybe there's some new information here, and I don't want to overwhelm everybody with some of the details. So casing is something that you will notice from the ground up of your well. It's the pipe or tubing that's installed in the ground to support the sides in the hole. So typically you will see that they're made of steel or concrete or plastic. There's a dug well here that has a concrete casing, and this is a drilled well that has a steel casing. The casing must meet strict requirements to ensure it does not allow passage of surface water and foreign materials in from the ground surface or gas from the ground out of the top of the well. So it must be watertight with watertight joints. So steel casings will be welded to be joined, and concrete casings would be sealed using some sort of a sealant between the joints. They must be made of new materials. They must extend at least 6 meters below ground surface and at least 40 meters above ground after mounding. And the mounding, as you see it here, is intended to provide water shedding away from the well during wet conditions. A well cap refers to the cap that's placed on top of a drilled well. It should be a manufactured vermin-proof cap that is vented but then sealed all around the casing and the electrical conduit line that exits the well. So this type of well cap allows for the passage of gas through the vent, but does not allow the entry of insects or other little things, as the vent is screened and all other openings are watertight. So here you have a few images. This is a really well-constructed drilled well. This one is missing a cap, and this one has gaps along the outside of the between the casing and the cap bottom, which would allow bugs and other little things to enter the interior of the well. Well covers, like those observed on these dug wells, are often used on these large diameter concrete wells. Because a watertight cap would have no openings, gaps, or cracks, the concrete covers can be really heavy to move for regular inspection. So then you have the option of installing something like this, a polylock, which allows the well to be more accessible and avoids damage every time you need to remove the cap and replace it. You don't want to damage or crack the structure. So this is a really good solution. This type of cap allows for water to potentially enter through the square here. It's not perfectly sealed. And this one just doesn't have a cover at all. And that opening's large enough to allow, small animals or even children to fall into it. The installation of equipment is an activity that's also considered construction in the well's regulation because it constitutes an alteration to the well. And so during the construction of a new well, a pump line must be installed in the well. So a hole must be cut in the casing to pass the water line from the inside through what's known as a pitless adapter. So that's this thing here. And that allows for all of your conduit to be buried rather than above ground. So you don't have all of that pump equipment exposed. And you'll recall that pump installation does require a Class 4 technician license. Once the well is constructed and the casing's in place, the space that remains around the casing from the original drilling or digging will need to be filled. And this is a critical step in maintaining the quality of the water in the well and protecting the groundwater in the long term. If it's not sealed properly with the right materials, surface water and any other materials that can enter from the surface have a direct entry route into the aquifer, or at least deeper into the well opening. At the base of the well, where the well is drawing water from, you should be using clean granular material to allow the water to pass into the well from the aquifer. And along the sides of the rest of the length, and we call this space the annular space, you should be using a sealant that both prevents the passage of water down into the well or gases out of the well. Well tags, like we see here, are required to provide a unique identifier to the well, linking the well that's in the field to the well record. Tags, you obtain them from the ministry, from the well's help desk, and are affixed to the well permanently before completing the structural stage of construction. It must always remain visible and in good condition, and a broken or missing tag must actually be replaced. Well records are the documents, and this is an example of what the form looks like of a well record. These are the documents that need to be submitted to the well owner and to the ministry by the person who completed the well. And it provides all of the information about the well's location, construction, the geologic setting, the water quality and quantity information. The records we receive are uploaded to the well's records map, which I've already talked about a few times now, where any person can access that information. And you can search by tag number or address. And so once you're done the well construction, you need to purge the well to remove all the drilling debris that was generated through the construction. You should be purging that until the water comes clear. A yield test should be done to ensure that you have good water supply. The well should be disinfected to address any bacteria that may have been introduced through the construction. And the final step would be grading and mounding around the base of the well. So the person completing the well has to provide the well owner with some assurances that the well was completed in accordance with the regulation. There's a standard information package, and there's pictured the first page here. It's a 2-page document. It provides general maintenance and inspection guidance. They must measure the depth of the well in the presence of the well owner, provide a chlorine residual test after they've disinfected the well, as well as a 1-liter sample just to show visually to the well owner that the water's clear. So now we'll dive into the responsibility of the well owner. So once the construction is completed, the well's regulation states that the maintenance of a well, such that entry of surface water and foreign materials, and this is the language directly from the regulation, it must be constructed such that surface water and foreign materials is prevented from entering the well. So it's been my experience as an environmental officer that this is often overlooked, this well's maintenance requirement. We'll respond to calls from well owners that their well appears to be contaminated, and then when we respond, we notice that the maintenance on the well is very poor, and it's likely just being self-contaminated by surface water entering around the annular space or a poor cap or things like that. So our maintenance checklist suggests an annual inspection, but your well is probably in your front or your backyard, so it's a good idea to have a look at it as often as you think about it, such as like when you're cutting the grass or something after a rainfall or a snow melt is also a really good time to have a look at your well, because that's when it's easiest to observe how the water is moving around the surface of the well. And if there's any ponding or anything nearby, it might suggest that some additional maintenance is required. So here are some common issues that we've observed. Some of these are photos that I've taken as an environmental officer. The first one on the left has a large gap in the annular space around the casing, which surface water can enter, not to mention even mice or snakes can get in there, and we have seen those things in wells. They can contaminate the groundwater supply. It can also work the other way, allowing gas to escape from the ground out if there's any gas present. And we like to assume that there may be, and that's why we want them vented and outside. The second image shows a well whose casing does not extend the required 40 centimeters above grade, leaving it vulnerable as it would become less visible than the one that you're seeing actually in the background over here. This is another well, it's a monitoring well, but it's got the proper height. A well that is not extending the full 40 centimeters would not be as visible, and it would only take 15 centimeters of snow to bury it. And then the other two are wells that have no cap or covers. And the one on the bottom here has quite a large opening. So these present an even bigger risk because we know that these holes are open all the way to the bottom of the well, which is an even more direct access than the one where the annular space is open probably. And so you are more easily contaminating the aquifer this way. And as I mentioned earlier, this picture, the dug well's hole is actually big enough that someone could fall into it. Someone small enough could fall into it. And these are two images that are taken from the inside of the well casing during an inspection. It shows water jetting into the well through the casing in this particular image, which means that there are holes from corrosion or maybe improperly welded joints. And so it's allowing water from that aquifer to enter through the casing, which is supposed to be watertight. And over here, you have something similar. Some holes are allowing roots to grow through the casing joints or holes in the casing. So we have published at the ministry a checklist to help well owners properly inspect and maintain their wells. It also provides information on when you should be contacting a licensed person to do the work, which is something you should consider if you have never done a very thorough well inspection, or you've never had a licensed a technician come and evaluate your well. They can do a more thorough inspection on the interior of the well a little bit more safely than the average person. You have to consider that you're working with electrical conduits and equipment, and this is your drinking water, so you want to make sure that you're being extra cautious when you're conducting the work here. So this is a abbreviated version of the checklist. The checklist online is much more detailed, and we provide a link to that at the end of this chat, in the chat. And so you'll be able to go and see the full checklist, but here I just kind of go over the broad strokes. So it's suggested that if you don't already have a copy of your well record, that you try and find it, because maybe there is one out there from the previous owner or the person that might have drilled it before you lived there, or maybe you never received one, but maybe the driller submitted it. It's possible that it wasn't completed and it wasn't submitted and it doesn't exist, but it's always good to try. And some of the newer wells you may not be able to find on the map because there is a bit of a lag time in the upload. So hold tight if you just drilled a well. You should already have a copy anyways from your driller. And then if you haven't done that inspection by a technician, and you do one and they recommend some upgrades, anytime there are upgrades or alterations to your well, a new well record would need to be generated anyways. So you would then have a current one. So it does say again here that it's a visual inspection is recommended annually or more frequently, but like we mentioned earlier, it's better to do it more frequently than that. So the basics of the well owner maintenance include observing for visual signs of routes of entry for surface water or other foreign materials into the well through the top of the well or around the casing. It also includes taking stock, and Trent mentioned this earlier too, of any possible sources of contamination that you may have near or on your property. So are your chemicals stored somewhere safely away from your well? And if they spilled, would they be able to enter the soil and groundwater? Is your septic system being properly maintained and serviced regularly? Are you also keeping track of your records related to your well? Do you have your well tested as often as you could? Have you addressed any comments the health unit made about their last results of your bacteriological tests? And have you ever tested for other chemical parameters? Or has this been done recently? So these are some sort of things you can go over on a regular basis to ensure that you are taking the best care of your well. It's recommended, like I mentioned, that any extensive well maintenance or inspection that's undertaken be done by someone licensed, or at least the very first time, have someone licensed come and show you the basics of removing the cap safely and doing any sort of visual examination of the interior. It's definitely highly recommended. So we've talked about testing and testing for different compounds. Your health unit offers the free testing for E. coli and total coliform. So these are your basic bacteriological tests, and they give you a really good indication of whether you're being contaminated by surface water or septic or manure. And they'll also offer you advice based on these results. And they offer you advice based on any sort of non-potable water result. They recommend doing this test at least 3 times annually. And so you can visit your local health unit website for any health-based advice for domestic well users. And we can provide in the chat a tool that you can search for what health unit is your health unit based on your address. Private labs are what you would use to conduct broader chemical parameter screening. So in Ontario, we have drinking water standards. So these tests could tell you about the potability of your water with respect to sodium or metals, for example. You can also test for gases, but it may be best to have a professional collect these samples, especially if you suspect gases in your well. And if you suspect gases in your well, you should also be reporting that to the ministry and the fire department. And then if there's any other suspected changes, so you're noticing things that are different about your water quality, the color's different, the odor's different, there's a lot of sediment suddenly in your well, you can report these to your local Ministry of Environment, Conservation and Parks district office, and we can provide a link to finding out where that district office is for your area. It's not going to be the same as your health unit necessarily. And then based on site-specific information, we might be able to help you determine if there's a source for that contamination. And if it's not contamination, also it could just be a natural occurrence because we had a really heavy rainfall, and that happens more often than I think we think. There's another handy table that you can consult when you're trying to determine the cause and solution of a problem that you're observing. And again, we will provide a link to this, but it's a very helpful tool. It's called Common Well Problems, Causes, and Rehabilitations. It's in Chapter 11 of our guide, and it'll help you decipher some of the typical issues and how to address them. It covers well pump issues, observations and water quality changes, water supply changes. It'll also indicate to you whether you should call someone to help you resolve a given situation. So now we'll spend the last part of this presentation, and we're close to the end. We're on slide 37, and there's only 47. But this we'll have a few slides here on well abandonment because this is another really important topic. So as you've surely heard before, improperly abandoned wells can pose a really serious threat to safety. Often wells that are not properly abandoned are not left open intentionally by the current property owners, but are discovered, unfortunately, sometimes after an accident has occurred. So it's important to evaluate as best possible whether there are any wells that may be abandoned improperly on your property. This is more common in farm properties or other properties that had outbuildings that may have been serviced by a well, um, or where there may have been multiple wells that have multiple uses on a property. So some of your larger properties. You can start by reviewing the well's record map. Might give you an indication of wells that may exist on your property that you're not aware of, or just doing a survey of your property carefully whenever you're new to it. Here's an example of a well that wasn't properly covered and it allowed a moose calf to fall in, and thankfully it was able to be rescued and did not sustain any serious injury. The regulation outlines various scenarios where a well must be abandoned unless an exemption applies. And so these include situations really where the well's regulation is not met. So when the construction of the well is discontinued before it's completed, if the well is dry, if the well produces mineralized water, that's water that is salty or sulfate rich. If the well produces water that is not potable otherwise, so it would exceed a drinking water standard in Ontario. If the well contains natural gas or allows for the passage of gas between formation that affects others, or if the well was constructed in violation of the well's regulation. A flowing well is another example of a well that would need to be abandoned properly unless an exemption applied. So in order to be exempted from the abandonment, the well would need to be corrected to some degree and equipped with treatment or otherwise managed in a manner that returns it to a compliant status or at least reduces its risk to harm human health, environment, and safety. So a few different approaches for this. If your water that the well that you've drilled produces water that's mineralized or not potable, you would go to your local health unit and seek approval from the medical officer of health to continue using that. And usually that's in situations where you're not planning on using that water for human consumption. Like, for example, you want to use it for irrigation, right? Only. And so then you would be allowed to only under those circumstances. And if the ministry gets involved in a request for relief from abandonment, the matter has to do with construction violation, gas and wells, or flowing wells, typically. And there's a heavy burden to prove that the measures that will be employed will be effective in correcting the risk to human health, safety, and environment. And so some work is involved in analyzing that, and we don't issue those very often. So now we'll focus on two scenarios where well abandonment is typically required. Natural gas being in your well can be harmful to your health through exposure at high enough concentrations, or can even cause an explosion risk if the concentrations are very high or it's allowed to accumulate in a space. These wells would need to be abandoned properly to avoid harm to the well owner through its entry into the water system and possibly the creation of a pathway between formations in the ground that can affect other users or exit at the ground surface and into confined spaces. So seeking relief from abandonment from the ministry is discretional and requires an extensive study into the risks and mitigation measures that are proposed. The well owner would have to ensure that any conditions that are imposed on the approval to maintain the well despite the presence of gas are followed at all times. So they become a piece of law that applies to that particular well. Flowing wells are another scenario where abandonment is usually required unless measures are taken and approved to control the flow of water from the well. They occur when the water pressure in the aquifer is elevated enough to cause the water to flow out the top of the well or out of the ground around the well. And it can cause flooding issues and interfere with the supply of other wells in the area because it sort of drains the aquifer. Again, a study of the cause and treatment options must be submitted to the MECP for approval to obtain relief from abandonment in this situation. These are a little bit more common because they're easier to control than a gas issue, but it all depends on the very site-specific situation. So when you're abandoning a well, you should be doing this with the expertise of a licensed well technician. So generally, if you have a drilled well and you need to abandon a drilled well, you would use the same class of technician to do that abandonment, or a class 2 if you have a dug well. There's a 9-step process. It's in our manual, and there's a technical bulletin on it also. It includes removing the well tag and all the equipment that's inside the well, and the casing, if you can, from the hole. A key feature is selecting the right sealant material, which will depend on the diameter of the well, the water conditions. Some sealants that you would typically use wouldn't work because they interact with gas in wells if that's present. So a well record is then produced following the abandonment of a well. And so before we move on to the final message, it's a good time to pause here to really drive home this message about the well owner's responsibility to properly maintain their well, regardless of whether you are the person who had the new well constructed or even if you knew about it. The steps to maintaining your well can be very simple, and the simple steps make a big difference in the quality of the water that's being used in your home and also the preservation of the groundwater aquifer that you're relying on, and so is everyone else in your area. So if you find yourself in a situation as a well owner where there's poor maintenance that has led to the impairment of groundwater or to the water supply of another property, the costs of failing to maintain the well can inflate quickly and may be associated with compliance action to resolve some of these issues. So here we're at our final slide. So I'm just going to summarize that the ministry regulates wells in Ontario by overseeing the licensing, the well construction, maintenance, and abandonment. It's the last time I say it. I'll promise that you are responsible for your well to protect your drinking water source, your health, and the groundwater source. So please hire the properly licensed contractors and technicians to undertake any work required to be completed on your wells or for any new well construction. And finally, conduct those regular maintenance inspections on your well and have it tested regularly. Thank you very much, everyone, for your attention.
Thank you, Melissa, for that wonderful presentation. So next will be, 1 second. I'm going into a bit of a into our question section, but first we want to hear from you. So now that our presentations are concluded, we'll have 5 poll questions that will come up for you. We'll give everyone about 2 minutes to select the options that best apply. Once you select your answer, hit the next arrow to move to the next question. And when you reach the last question, please hit submit. If you're on mobile, the device, mobile device, the polls will pop up like a banner and you'll have to select a view first to open up the poll questions. And then following the polls, we will discuss the pre-submitted questions and as many questions from the chat as we can. So feel free to add any more questions to the chat now. If you have any for our guest speakers or myself or our other staff. So. All right, thank you to everyone who helps participating in our poll questions. These answers will help us ensure that our webinars will continue to improve over our series. As I mentioned before, we have a septic specific webinar coming up next month. And it's now time for the question section. So As I mentioned, we had lots of pre-submitted questions. We tried to consolidate some of those, so we'll be going through those first. So I'll be asking the question, and Melissa will be answering them and we'll move through them. So how to manage your water well in times of water shortage?
Okay, so we do have a page that's dedicated to this particular issue. It includes a series of questions and answers to help well owners troubleshoot the cause of the water shortage and identify different solutions. So water shortages can be caused by dry conditions, excessive use of water in that area, problems with your pump. So one thing we do caution against is filling your well with water. It can introduce contamination and it won't necessarily fix your water shortage during a drought, for example, because the water won't stay in the well. So you should begin by contacting a licensed technician to determine the cause of the shortage in the first place, and then they can recommend some solutions. But a link to that will be posted in the chat, or it has. Thanks, Natasha.
Thanks, Melissa. Next question is, how can climate change affect my well?
Okay, yeah, the short answer is we don't really know. We do know that there's a greater weather event uncertainty associated with climate change, and so there is the possibility for increased frequency of heavy rain events, flooding, droughts, wildfires, and so this makes the need to ensure that your well is properly constructed and maintained even more important, because the existing requirements to help protect the well and the water source from contamination from what's occurring at ground surface.
Great. Are there general issues and best practices for wells and basements versus outdoors?
Right. Wells and basements, yeah, they do occur, and so then they present a number of challenges, which is why under the wells regulation we only ask that we require that the a site of a new well be selected so that the well is accessible for cleaning, treatment, repair, testing, inspection, visual examination at all times during and after completion of the wells. So this is one of the reasons we want the wells to be outside. Another reason is to allow venting, allowing the passage of gas. So if gas is present, there's a risk of gas entering the dwelling and accumulating. And so wells located inside structures present a number of accessibility issues, also related to the repair and abandonment of a well.
Great. So the next one is kind of related to that, and we've had a few questions in our chat about it. So what should we know about toxic gases in drinking water wells?
Yeah, so toxic natural gases, so we're talking about hydrogen sulfide, methane, even radon, they do occur. And the well may create a pathway for the gas that would otherwise be contained in the ground to escape. In a properly constructed and maintained well, though, gases should only pass through the well cap or cover through the screened vent. So well cap that has been constructed in accordance with the regulation will also not be located indoors or in confined areas where those gases would be able to accumulate. Um, if natural gas is found in a well, though, the gas would need to be managed, properly vented, or this well would need to be abandoned. And issues with gas in a well should be reported to the ministry. You can report them through the district office if it's not an emergency or something, but you can call the Spills Action Center, and you'd want to also notify the fire department if you were worried about that. And I did see in the chat that there was a question about how would you know if there's gas in a well, and sometimes you don't, but there are other signs, and those are also listed in the guide. You could see bubbling or a milky look to your water. So those are some of the common signs, but other times it's not that obvious.
Great, thanks. So going a little different direction now. What to do if pesticides have been sprayed around my well by the previous owner or neighbors?
Okay, yeah, so that's a good question too. The use of pesticides or any other chemicals for that matter near a well is always discouraged, especially when the state of repair of that well is poor or unknown. But if the well meets the minimum requirements of the regulation and the products are being used in accordance with the label directions, and this is speaking about pesticides which are managed, their label instructions are managed and regulated, it should reasonably prevent the entry of materials from the surface that are being used responsibly. But if you suspect that your well has been contaminated by any chemicals, you can obtain a sample and submit that to a private lab, or you can also contact the local district office. But with the private lab, you can always there's a pesticide scan test that you can request.
Great. So what is what is recommended for well water treatment?
So well water treatment that's required or might even be desired depends on the existing water quality and the homeowner's preference. So it's very individual. The ministry doesn't recommend any water treatment technologies broadly, but if there's contamination or potability issues, would work with well technicians, the homeowner, the health unit, and any other professionals that may become involved um, to help identify the cause of the potability issues, correct those first, and if treatment is required, then consider those options to return the water to a potable condition.
Thanks. Are there aquifer maps available to see where our water comes from?
The ministry doesn't have in open data any aquifer maps, and I'm not aware of any specifically, although I would check with the local health unit or the conservation authority. They may have groundwater mapping that's available through their agencies.
Yeah, I think most conservation authorities should have some groundwater mapping available.
Yeah, you can get some information from your well record. I mean, it depends what you're looking for, but if you look at well records or even well records that surround your property, you can get information about the average depth of wells or when water was encountered during the construction, the specific soil types that were encountered during construction. So there's some information that's available through the well records, but you do kind of have to make a study project of it.
Right. So how do I ensure my neighbor isn't drawing too much water from our shared resource?
But we don't really regulate the amount of water one person is drawing from their well for a domestic purpose. But if one person's water use does lead to adverse effect or impairment of water on on your property, you can bring that to the local ministry office to discuss the situation. It has occurred where maybe an industrial use of water that would be under a permit to take water or not during really dry conditions may lead to a bit of a dip in your supply. Those are the kinds of situations we may also become involved with because there is often conditions in a permit to take water that limit the drawdown during dry conditions. And so that would normally just fix itself once the drawing is reduced.
Right. So what should we know about well maintenance? I think you touched on this a bit, but
We did touch on a little bit, but that's okay. It's another plug for it. Do it, please.
yeah.
We have resources available on our webpage, and so that's shared with you in the chat. And then we outlined our suggested best practices for well maintenance in this presentation. The site would also include suggestions for water well sampling for a variety of parameters and how to address a variety of really common issues with well water. So I would go to that best practices chapter, and it's a bit of light reading,
Great.
but it's all there.
All right. So that's the end of our pre-submitted questions. Natasha, was there any that from the chat that we haven't been able to get to at all?
Yeah, there was one specifically asking about how to drill your well, or specifically a drilled well. If you could answer that one, Melissa, that'd be helpful.
Okay, so the question's how to drill your...
How
Sorry.
to bleach your drilled
Oh.
well.
Okay. Sorry. So there's a link that we can provide to Public Health Ontario's well disinfection tool. And actually, maybe what I'll do is, can I take control of this screen?
Sure, yeah.
And I'll share the link to it in the chat.
I've already got you covered.
You
on
got that?
one.
Okay. All right, hold on a second. I'll share my screen up here. So we're not Public Health Ontario, but this is a partner agency, so you can consult this well disinfection tool, and it provides you with, without having to do the calculations yourself, it provides you with some information here that you can enter the diameter of your well, the depth, if you know these things. Not everyone does know these things, so and again, if you have to remove your well cap, I still suggest that if you've never done that before, to hire a technician to do that with you the first time, or just hire a technician to do it. But I would also just contact the health unit about some advice related to that. And do you want me to show the records map?
Yeah, that would be great.
Okay. So here's the well records map. And Natasha, you shared that link already?
Yes.
Okay. All right. So here is what it looks like when you open the link. So you can search by your well ID, which is an ID that's found on your record, or by your well tag. So that's right on your well. There's a tag. It starts with an A normally. Or you can search by location. And so that's what I'll do here because I don't have a tag handy. But say I put in Martintown. Okay, and I can go, all the blue dots, as you recall, are the well records that were submitted to us. So here I'm going to click on this. You got to use the hand to click, and then it'll show up the well ID, the tag number. Okay, and you can open the well record like this. And so at the top here would be the well owner's information. So that information is redacted. And it has all the information that you would need to use to fill out a well record. So it talks about the depth of the well and what the soil looked like, or the material looked like whenever you were at that depth. You would have all the results of your water testing here. What they sealed the annular space with, here they used cement grout. What the water use is, the method of construction. So here it's a drilled well. They used rotary drilling. And then the general location, there's always a little sketch here. The well contractor and technician information is here. The piping or the casing that was used, they used a steel casing. Okay, so this is what a well rec would look like. And so it's a really easy tool to use if you want to try and see what's going on in your neighborhood or on your own property if you've never used this tool before.
That's great. Thanks for that demonstration. And I'm sure it'll be helpful for those who are interested in finding their well records. We also had another question that asked, when a contractor installs a new well, who inspects it or approves the well for use?
Okay, so there's no formal approval for each well or inspection program necessarily. So we do respond to any complaints or calls we may receive about this, like someone observing a well being constructed that they don't particularly think is complying with the requirements. So we sort of have a responsive based program for wells. But there's no approval of a given well. So basically, you have to hire a licensed person to do the construction. And so that's the one way that we ensure that they are completed in accordance with the regulation. And then we receive the well record. And those well records may be screened for completeness. And sometimes based on the well record, you can tell whether or not it was completed in accordance with the regulation if we receive it. So Yeah, the short answer is because we have a licensing program, there's not a well by well approval program.
All right, thank you. And then there was another one that says, how often do you think our drinking water wells need to be cleaned or purified, for example, being bleached?
Yeah, I'd say that's a question for your health unit, your local health unit, because it will be very site specific also. Depends on whether or not you have bacteria that's coming into your well that you're observing regularly. You might be someone who may need to disinfect or consider a disinfection treatment in your home. Um, but some people never have to disinfect their well. So it's based on your preference and also the water condition that you're drawing.
Awesome. And then there was someone else who said, we have a new well and had it tested, hasn't been connected to our house yet, but there are a number of gases, methane and sulfur were found. What is the best way to filter the gases?
Well, yeah, that's a very specific situation. And so I would suggest that you contact the local district office about that because we would need a lot more information about how to best approach that situation. But as you heard in the presentation, if your well is producing natural gas, it does need to be addressed. Otherwise, you're facing abandoning that well.
Wonderful. Yeah. Yeah. If there are any kind of specific treatment questions, it is best to contact your local district office or health unit. They will have the best information for your area. I did notice there's a comment in the chat saying, please do not pour disinfectant from the top, no matter what the calculator tells you. I'd just like to say to that is if you were not comfortable bleaching your well, again, contact a professional and maybe watch how they do it so you're better prepared to do it next time. Do you have anything to add to that, Melissa?
No, I agree. I think that definitely all disinfection type questions should be going to the health unit.
Yeah. All right. Well, without further ado, I think that was the end of our questioning period. I'll leave it over to Trent, but thank you again for everyone who's participated.
Thank you, everyone.
And to Melissa. And we do have some webinars coming up. Trent, if you want to take it away.
Sure, yeah, thanks, Natasha. Yeah, as I've mentioned before, our next webinar will be next month, November 30th, at the same time slot, or sorry, 6:30 to 8 for that one, on our Septic Care 101. So similar process, we'll have a brief best practices presentation at the start that we'll be doing for all of them. And then we have an expert in the field to discuss septics. And then for 2024, we're looking to have a realty and rural drinking water webinar. So that's going to be targeted a bit more towards realtors and what they know, but the public is welcome to attend that as well. And then a rural drinking water and human health webinar in March. So we have a registration link open for the septic care one already, and we'll get links for those ones in 2024 when we have the sort of dates and times nailed down. So for more information, you can go to the Quinte Conservation website or the Trent Conservation Coalition Source Protection website, as well as Cataraqui Conservation. You should be able to find links to the webinar series there. And if you'd like to get in touch with any of the panelists about the webinar series, or if you have more follow-up questions that we maybe didn't get to, you can find our contact info there. As I might have forgot to mention at the start, that this with this being recorded, this presentation will be uploaded to Quinte Conservation's YouTube channel in the coming days. So if you'd like to rewatch it there, that's where you can find it. So yeah, thanks you everyone for attending. Thank you again, Melissa, for the great presentation and help answering these questions. I hope everyone learned a little something about wells today. So take care.
Thank you. Have a great evening, everyone.